Okay, we're going to continue with our examples in these set of notes. First one is to write a recursive and explicit rule for the sequence, which we just did at the end of the previous video. Again, I'm going to do two diversions for the recursive. Again, the only difference there is that the first one talks about the previous term, the second version talks about the next term using the n+1. You generate the stuff the same way. Explicit, again, I'm using parentheses. Always to the n-1 for that. Right, now we're going to use these rules. We're going to find our two formulas and then maybe find a term in the sequence. So we're going to find A20 given A1 is 3 and R is 2. For recursive, I'll just write the one version this time. The explicit is AN 3 times 2 to the n-1. Now in this situation you don't have to use the parentheses, but I like to use it pretty consistently. And then if we're finding A20, we just plug in 20. And this should give you a fairly big number. So 1,572,864. Again, you'll notice, unless we're dividing, that you're going to get some pretty big numbers for term values. We're going to do the same thing for our next one. First term is 2187. Here we actually have to calculate the common ratio. So if you're dividing something that's going a smaller number to a bigger number, I would always use the fraction tool for this, because most likely your ratio will be a fraction. In this case, it comes out to 1/3. We'll write a recursive and an explicit. And then once we have both formulas, we'll use the explicit to figure out the 10th term. In this case, when you calculate it, again, using the fraction tool is helpful. We'll get A10 is 1/9. Okay, so just like with arithmetic, those are the easier ones. You're given pretty much all the information you need to plug in. Now we're going to get into some harder ones where we have to find missing values.